equation of tangent in slope form. So equation of tangent in slope form. That means when we are connected with the slope, tangents are perpendicular, or find locus of a point where tangents intersecting at 60 degree, 30 degree, 90 degree, so many cases may come. Then we will use this concept. That means somehow we are connected with angle or slope, then we will find equation of tangent in slope form. Okay, let line y is equal to mx plus c intersects or touches the parabola y square is equal to 4ax. From here we will get some important conditions. The line is secant, line is outside, line is intersecting, line is tangent. All those conditions we can get from here. The same analysis treatment we have done in the chapter of circle also. A line is there, possibility line may be outside, line may be intersecting, or line may be touching. All these conditions we can see. So for this the method is let us find this intersection points, etc. So if I will put y is equal to this mx plus c in this equation, that means I will get mx plus c whole square is equal to 4ax, y square is equal to 4ax, squaring. So m square x square plus c square plus 2mcx is equal to 4ax. So from here I will get m square x square plus 2x mc minus 2a plus c square is equal to 0. So this is the equation of a line. Equation of line and intersection of these two, circle and line. Now there may be conditions that this line may be intersecting. If this line is intersecting at 2 points, we will get two distinct roots, x1 and x2. If this line is not intersecting, it will have no roots, imaginary roots. So we will find a d, discriminant of this line. So discriminant of this line d is equal to b square minus 4ac. So d is equal to b square means 4 mc minus b square minus 4 m square c square. That means I can write as 4 outside m square c square plus 4a square minus 4amc minus m square c square. So this will cancel out. So again I can take 4a, 16a outside, 16a. If 4a is outside, a minus mc. This will give the conditions. That means if this equation is having two real and distinct values of x, so d must be greater than 0. That means if line is, if case 1, if d is greater than 0, that means from here a is greater than mc. This implies line is intersecting, because I will have two real values of x, x1 and x2 corresponding to any 2 points where this will intersect. So in this case, line is intersecting. Second case is if d is less than 0, that means it is not intersecting. This equation have no roots, so line is non-intersecting. That means a minus mc is less than 0 or a is less than mc, then it is non-intersecting, line is outside, non-intersecting. And the third case is if d is equal to 0. If d is equal to 0, line is intersecting, touching. That means I will have equal roots. Equal roots means x1, x2. Here x1 is equal to x2, y1 is equal to y2. That means I will get only a unique solution. So this is very important. This gives the condition of tangency. Condition of tangency. Here to understand, this is very important. This concept generally we can use for any second degree equation, whether it is parabola, ellipse, hyperbola or circle. Any time we can use condition of tangency. So this is particularly of our interest. So d is equal to 0, that means a is equal to mc, a is equal to mc. So this gives us c is equal to a upon m. This value c is equal to a upon m I will put in this equation. So my equation of tangent, from here I will get equation of tangent y is equal to mx plus a upon m. This will give me equation of tangent in slope form. Y is equal to mx plus c. C is a upon m. So again, just a fast recap of this, what we have done. Parabola is given, line is given. I have to find whether they are intersecting, non-intersecting or touching. So I will solve them for y. Y is equal to mx plus c, I will put here. So mx plus c whole square is equal to 4ax. Squaring, making a quadratic in x. X square terms, x terms and constant terms. Now, possibility is if this line is intersecting like this, then it will have here two values, a and b. For x1, y1 you will have, and for this you have x2, y2. That means those x1 and x2 two roots will come from this. So if this equation is having real roots, then d must be greater than 0. Then it is intersecting type. If this equation is having imaginary roots, that means this is having no roots. So a is less than mc, d is less than 0. If this line is tangent, x1 and x2 will become equal. So a is equal to mc. So condition of tangency is c is equal to a upon m. From here I will get y is equal to mx plus c and replace c with a upon m. This is the equation of tangent to the parabola.